keeping up with AI is a full-time job these days, right?
Absolutely. It's incredible how quickly things are changing.
So today we're going to take a deep dive into something that might just change the game even more. It's called GRPO.
Group Relative Policy Optimization.
Right. And in super simple terms, it's like a secret sauce recipe for AI to reason better and learn way faster.
Yeah, we're going to break down what GRPO is, why everyone's so excited about it, and what it could mean for the future of AI, especially for problem solving and stuff like that.
And to get the full picture, we've got some awesome sources lined up. We'll be looking at what Christopher S. Penn, the marketing AI guru, thinks, and then Nathan Lambert, who's deep into reinforcement learning research. Plus, we'll be drawing on some analysis from the Arxiv Dives blog. They're always on top of the latest research.
Exactly. And our goal today is to make GRPO crystal clear for you. Without needing a computer science degree, we want you to walk away with the core ideas, its potential impact, and why it matters, even if you're not, coding AI yourself.
Sounds good. So let's get started. What exactly is GRPO?
Okay, so at its heart, GRPO is a type of reinforcement learning algorithm, or RL for short. And RL is all about training AI by giving it rewards for doing things right.
Right, like a virtual pat on the back for the AI when it does good.
Exactly. GRPO is a very specific and quite clever type of RL that focuses on turbocharging the reasoning abilities of AI models.
Now, this came out of the work done by the DeepSeek team, right? Their R1 reasoning model was like the talk of the town.
You got it. The brilliant minds behind the DeepSeek R1 model are the ones who developed GRPO. And to really understand what's so different about it, Christopher Penn uses this really cool analogy about a chef.
Ah, yes, I remember that. Can you remind us?
Sure. So think of a chef who's trying to perfect a dish, maybe a pizza, right? Traditionally, they'd get feedback from their customers, things like needs more oregano or the crust is too thick. It's all about that external feedback loop.
Right, a lot of trial and error based on what other people think, which can take quite a while.
Yeah, exactly. Now, GRPO flips that script. Instead of just relying on outside opinions, the AI model, which is like the chef in Penn's analogy, creates multiple versions of the solution internally. So imagine the chef making several pizzas at once with little tweaks to the ingredients or cooking method.
So the model's kind of like running its own little experiments in its virtual kitchen.
Precisely. And here's the key. It evaluates these internal experiments based on its own built-in criteria, its own taste, if you will, before it ever serves up the final result. This is what Penn calls the internal taste test, and it's what makes GRPO incredibly efficient. It's doing its own quality control checks throughout the training process.
Got it. So by not always needing input from the outside, it can learn and improve much faster.
Exactly. It significantly cuts down the reliance on those long-winded external feedback loops, allowing the model to refine its reasoning abilities internally. The big takeaway here is that GRPO empowers the AI to become its own best critic during training, making the learning process much tighter and more efficient.
So that efficiency is what's causing so much buzz about GRPO. But what makes it so significant in the grand scheme of AI?
Well, there are a few really big reasons. The first is exactly what we've been discussing, those efficiency gains. Arxiv Dives points out that GRPO could potentially slash the computing power needed for reinforcement learning by up to 50% compared to older methods like PPO, proximal policy optimization, for those who like the full name.
50% less computing power. That's enormous. What does that mean practically for the field?
Well, it means that AI research and development become way more accessible. Arxiv Dives actually showed this by turning a relatively small 1 billion parameter Llama 3.2 model into a reasoning model using GRPO. And they did this with only 16 GBs of VRAM. That's a tiny fraction of what was previously thought necessary.
All right.
So now even individuals or smaller research teams with limited resources can realistically get into training powerful reasoning models.
Wow, that's a huge step towards democratizing AI innovation.
It really is. Yeah. And what's even more exciting is that DeepSeek has openly released the mathematical formulas and the methods behind GRPO. They're fully committed to open source, which is really cool.
That's a stark contrast to some of the big tech giants that tend to keep their cards close to their chest.
Absolutely. And the open source AI community has wasted no time in putting it to work. Groups like Unsloth, as Christopher Penn mentions, have already demonstrated that GRPO can be used to fine-tune existing open source models, using relatively low computational power. So what was initially a standout feature of DeepSeek, those amazing reasoning capabilities could potentially be integrated into a vast number of AI models. Penn even throws out a crazy figure of 1.39 million models.
That's mind-blowing. So this isn't just about one specific advanced model. It could potentially raise the bar for AI reasoning across the board.
Exactly. It's about making smarter AI more widely available, and that's a big deal. This open approach really sets it apart from the more closed-off strategies of some of the major players in tech.
Okay, so we've got a handle on what GRPO is and why it's such a big deal. But let's get a bit more hands-on. How does GRPO actually work in a way that we can wrap our heads around?
Sure. So the process begins with the AI model generating multiple different outputs in response to a single prompt or question. Think back to our chef whipping up several different pizza prototypes based on the same order.
Okay, so instead of trying to come up with just one answer, the AI explores various approaches to the problem.
Exactly. ArcSviDyes uses a simple math problem about chickens on a farm to illustrate this. The model might generate different lines of reasoning, some leading to the correct answer and others may be going astray.
Right, so it's creating a bunch of potential solutions or paths to get to the answer. Then what happens?
Well, each of these outputs gets assigned a reward. It's basically a score that reflects how good that output is based on a bunch of factors. This could include things like the formatting of the answer, its internal logical consistency, and of course, whether it's actually correct. Interestingly, DeepSeek R1 actually used pretty simple techniques like regular expressions and string matching for these reward signals, which means you don't need a separate complex reward model.
So the AI itself, or some preset rules, act as the judge evaluating its own attempts. That's pretty cool.
It is. And here's where the group relative part of GRPO really kicks in. The algorithm calculates an advantage score for each output. Now, this isn't just an absolute measure of how good it is. It's determined by comparing the reward of that output to the average, and the spread or standard deviation of the rewards of all the other outputs that were generated for that same initial prompt.
So it's all about how each attempt stacks up against the others for that specific question. The model's like, all right, here are a few shots at this problem. Let's see how they compare to each other.
Exactly. This group relative advantage helps the model understand how well a response performs relative to its other attempts at answering the same question. Yeah. It's not just, is this a good answer on its own, but how does it measure up against the other solutions I came up with? It's like the model is setting its own internal benchmarks for success.
That's a really clever way to make the model learn from its own internal successes and failures.
It is. Then there's the KL divergence term, which is basically a way to measure how different two probability distributions are. In GRPO, this term, along with what's called the reference model, basically a snapshot of the original pre-trained model, helps to keep the model's learning on track. While it's busy trying to maximize its rewards and improve its reasoning, it ensures that the model doesn't drift too far from its original capabilities, like generating grammatically correct and coherent language. It's like a gentle reminder to stay grounded while exploring new possibilities.
Hey, don't forget the basics while you're out there getting smarter.
Exactly. It's about striking a balance between exploring new territory and retaining those core skills.
Now, AI research is always moving at warp speed. Are there any interesting nuances or ongoing research areas related to GRPO that we should know about?
Absolutely. Nathan Lambert brings up a really important point. While GRPO is exciting, it's not a completely brand new RL algorithm. It has strong ties to established methods like PPO and RLOO reinforcement, learning from other observations. What he emphasizes is that GRPO is a brilliant little tweak, a really smart adaptation that's proven to be super effective for training reasoning skills. And a big reason for this is its way of figuring out advantages by comparing multiple answers for the same question.
So it's an evolution rather than a revolution, but a very impactful one.
Precisely. And just like with any type of AI training, the quality of data is paramount. Research from both Kimi K1.5 and OpenReasoner 0 has highlighted that well-rounded training data covering diverse topics and difficulty levels is essential for effective reinforcement learning. What's really cool is that the Kimi K1.5 research actually explored using the AI itself to figure out how difficult the training prompts were.
That's so meta, using AI to judge the difficulty of the stuff it's learning from.
It is. And researchers are already busy exploring modifications to the original GRPO framework. There's a method called DAPO, for instance, that introduces things like 2 different clipping parameters to fine-tune the learning process dynamic sampling techniques per token loss considerations and reward shaping strategies to specifically control the length of the AI's responses.
So they're basically tweaking and refining GRPO to make it even better and tackle specific challenges.
Exactly. And another project called Dr. GRPO proposes even more changes. They're trying to address potential biases that might exist in the original GRPO implementation, like the tendency to prefer short correct answers over longer, more detailed, but maybe partially incorrect ones. And they're also working on minimizing biases related to the difficulty of the questions themselves.
It sounds like the AI research community is really digging into the nuts and bolts of how GRPO learns and how to optimize that process.
Oh, absolutely. And while these modifications are aimed at improving the learning dynamics and preventing issues like the AI generating super long or repetitive responses, Nathan Lambert makes a really insightful observation. He points out that the ultimate measure of success is how well the trained model performs in the end. And that performance is often most fundamentally tied to the quality and diversity of the data it was trained on.
Right. You can have the fanciest algorithm in the world, but if you feed it bad data, the results are going to suffer.
Precisely. And it's also worth mentioning that OpenReasoner 0 managed to get really impressive reasoning results. Using the more established PPO algorithm, combined with a technique called GAE, or Generalized Advantage Estimation. This just goes to show that while GRPO is powerful, it's not the only path to building really capable reasoning AI.
It's one powerful tool among many in the ever-evolving world of AI research.
Exactly. It's all part of this exciting journey of figuring out how to create more intelligent and capable language models.
So let's shift gears a bit and think about our listener. What are the key takeaways from all this GRPO stuff? What should someone keep in mind strategically when looking at these advancements?
Christopher Penn offers some really solid advice here. He says, embrace flexibility in your AI strategy. Don't get locked into specific vendors or technologies because the field changes so fast that being rigid can hold you back.
Stay agile and be ready to adapt as things evolve.
Exactly. Keep your focus on your core processes, your goals, and the reasons you're using AI in the first place, and be prepared to switch to different models and technologies as better options emerge, like we're seeing with GRPO.
So it's not about getting attached to a specific tool, it's about staying focused on the outcome you want to achieve.
Absolutely. And Penn also brings up the potential for EQD fear, uncertainty, and doubt surrounding newer technologies like DeepSeek. He suggests that some of this might be intentional, to protect existing market share and competitive advantages.
It's a competitive world, so that kind of maneuvering wouldn't be all that surprising.
Right. And he raises a really crucial point about data privacy. He says while open source models that use GRPO can be deployed safely on your own servers or within your own country's borders, you got to be careful about using the Chinese hosted version of DeepSeek, especially for sensitive data, because of data privacy concerns.
That's a great point for anyone thinking about using these technologies. Always be aware of where your data is going and who has access to it.
Absolutely. And finally, Penn draws a really interesting parallel to the world of open source software. He talks about things like Linux and Apache. These are foundational technologies that are freely available, and the real value comes from the services and applications built on top of them. He thinks AI might be headed in a similar direction, with core AI models becoming more and more accessible, and the real innovation happening in the specialized apps and services built around them.
That's a pretty compelling vision for the future of AI, a much more open and democratized ecosystem.
It is, and GRPO seems to be a major driving force behind that shift.
All right, so to wrap up our GRPO deep dive, the main takeaways were that GRPO is this efficient and accessible reinforcement learning technique developed by the DeepSeek team. It significantly boosts AI's reasoning abilities and could really open up AI development by lowering the computational barriers. And it's a hot area of research in the rapidly evolving field of AI.
Yeah, and I think the most amazing thing here is the idea that AI models can do their own internal evaluations and comparisons during training. It's a fundamental change in how we think about reinforcement learning for complex tasks like reasoning.
It's like giving AI its own internal compass for what makes a good answer instead of always relying on external feedback.
Exactly. Now keep in mind that this has been a high-level look at GRPO. There's a whole lot more to explore if you want to dive into the technical nitty-gritty things like the specific math behind it, the impact of different reward functions, and the ongoing research into modifications and optimizations of GRPO.
So there's plenty more to learn for those who want to go deeper.
Definitely. And to leave you with something to ponder on, think about this. With the rise of powerful AI models and techniques like GRPO, how is this going to fundamentally change how we solve problems and innovate in the future? What happens when sophisticated AI reasoning becomes widely available and democratized? It's a question with some pretty big implications.
It definitely is. It's a brave new world of AI out there, and we're just getting started.
Absolutely exciting times ahead.
Thanks for joining us for this deep dive into GRPO. We'll catch you next time.
See you then.